market and have partnerships with the German National Unemployment Agency. So we focus on delivering online training content on mostly unemployed people and help them get back to employment. So that's our main specialization, and I'm mostly responsible together with a colleague for our cloud infrastructure. Okay, so yeah, as some might know, Kubernetes usually gives us easy migrations and failover, so it comes with all kinds of features to provide us with yeah, like migration plans and stuff. So we don't need really to really think about how to approach certain stuff, because it handles a lot and abstracts away a lot of stuff in the background, which you normally don't need to know as a developer or also normal, like say, kind of operator that just needs to deploy some stuff. And we mostly have come to expect this as a simple fact that we can just use it and it will work, and we can trust this. However, what happens if such a migration goes wrong? So if we do something and we trust that it should work because it always worked. So this is what I'm going to talk about today. What happened to us a couple of weeks ago. And yeah, let me introduce today's protagonists. They are called node drain. So node draining is a feature of Kubernetes that moves pods of the drained nodes to healthy ones. So for example, you want to do maintenance work on some nodes, then you can drain those nodes, and Kubernetes will make sure that all the pods that are currently running on those nodes will get evicted and move to other nodes that are not being drained currently. So the workloads just continue to run on different nodes, and you can do maintenance on your nodes that are being drained. So that's usually good for planned maintenance work, as I said, for replacing or upgrading nodes. And the second part that hit us really bad here is the services abstraction and the kube proxy that implements this in the background, which usually makes sure that pods are reachable no matter which node they run on. So the client usually always reaches pods via the service IP or service name, and the service abstraction makes sure that this works just fine. Okay, so our initial situation was the following. So this is where we started. We had a Kubernetes cluster in Google Kubernetes Engine, and we had one node pool on this. And on this node pool, we had Ingress Nginx running as an Ingress controller and all other services. And yeah, those Ingress Nginx Ingress controllers were just behind a normal Google Cloud Load Balancer service, which just redirected all the traffic inside into the cluster by the Ingress Nginx, which then yeah, obviously put it redirected it to the background pods. So what did we do, or what did we want to do? So we needed to recreate the node pool, actually, because we had to do some maintenance. This was in particular, we needed to change the OAuth scopes of the Kubernetes nodes. So in Google Compute Engine, your compute instances get assigned some OAuth scopes that they can have authorization with their built-in service account, and so we needed to change that. And the simplest way actually is to recreate the nodes with the new needed OAuth scopes and don't mess with the existing nodes. So we figured, yes, this would be a simple exercise. Just recreate the node pool, or create a second node pool in parallel to the existing one, and then just simply migrate all the workloads over and kill off the old nodes. So the idea was to do just as simple as that. And we did that. We did a kubectl drain on all the old nodes at once. So this was the first part where we just blindly trusted our positive experience from the past that it normally all works. So we did a kubectl drain on all of the old nodes, and then we ended up with this situation. The first thing we noticed was, okay, no more traffic goes into the cluster via HTTP. So none of the backend services were reachable anymore. And then we took a deeper look into it and saw that though we did a drain of the old nodes. The Ingress Nginx pods were still running on the old nodes, but the cloud load balancer service, or the load balancer service that connects to the Ingress pods didn't have those endpoints anymore. So it only had the endpoints of the new nodes, but it didn't redirect any traffic via the new node pool to the existing pods on the existing node pool. So we didn't really expect what we ended up with, because those Ingress pods were still running on the old nodes, and yeah, no traffic was redirected to them anymore. This should not happen usually. Why this should not happen, I will get to in a minute. So let's see how the whole story unfolded.
So, Marcel, if you don't mind, I have a question.
Yeah, okay.
What was your upgrade strategy like for your applications running on each node? Was it just a simple drain, or you had backed up the applications running in your cluster before doing the
No,
drain?
this was a simple drain actually, because the applications in this cluster were all stateless, so we don't have any stateful services running there. So it was really simply, we do a drain and all the pods get restarted on the new nodes. So was the plan, and then we we go on with life. So this was the initial idea, because all only stateless services shouldn't have done any harm. Okay, what happens when you drain a node? So when you tell a node to be drained, it usually tries to move off all the pods from the node and recreates them on other nodes. And what also happens, the nodes that you drain all automatically get cordoned. That means those cordoned nodes won't accept any new pods also to be scheduled on it, and it will also be moved into a not ready state. What happens when a node gets moved into the not ready state? The Kubernetes service controller then in turn will remove the nodes that are not ready from the in this case the front end GCP load balancer backend config, and only the new nodes have been added. So we're faced with the situation as pictured earlier, that the GCP load balancer pointed only to the new nodes, but not anymore to the old nodes. So this was the first thing we noticed after we trained it. Okay, so the next thing, this is a snippet from the Kubernetes service controller source code. So it actually shows. So this is something where I dug into then to understand where it came from. And when a node is unschedulable, so in this case not ready, for example, it will get removed from the node, load balancer config. As I understood this comment, this was originally intended to filter out master servers from the from the backend config, because usually you wouldn't run workloads on the masters, only on the worker nodes. And so, but also removes all nodes that are not ready from the backend config. So this is something I didn't really know before, only found out when I dug through the source code later on. And also the other thing was that the Ingress Nginx pods were still running on the old nodes, despite the nodes being drained. Why was that? We also took some time to find out what happened here. We had some pod disruption budgets configured on some deployments, which were actually, this is the thing we didn't really look into. Those disruption budgets were not configured by us intentionally. They were just part of default values from a Helm chart we installed. So we didn't really look into it. But the thing is here, as soon as the disruption budget is hit, the draining of a node will just be blocked and stops when the number of ready replicas would fall below the specific disruption budget. And the thing is, because we drained all the nodes at the same time, the disruption budget would have not been satisfied anymore, and the draining operation stopped on all 3 nodes. So this was the reason then why the Ingress controllers still were running completely on the old nodes, and none of the pods have actually moved to the new nodes, whereas the new nodes were only then part of the GCP backend, GCP load balancer backend config, but not the old nodes. So we had, yeah, we had clearly a problem here. But still, we didn't expect it to be that big of a problem, because what usually you would expect, how kubeproxy works and with the service abstraction, even if the pods are not running on the nodes that are in the backend config from the GCP load balancer in this case, usually kubeproxy would transparently forward the traffic to the correct nodes where the pods are running. So this is actually what we expected. And it turned out this was not the case, and we also found out why it was not the case. Yeah, as I said, this was not the case. The usually, or the originally expected behavior did not hit. So we did further investigation. Why was this? Yeah. So we took a deeper look again at all the points where we might have messed up, and then I noticed here this is the service definition. We used the default deployment manifest from Ingress Nginx from the official repository, and this is the default service definition that comes with it. And what we noticed then is the external traffic policy set to local here. So, and why is this important? When you set this external traffic policy to local, exactly this behavior that kubeproxy would transparently forward the traffic to other nodes is switched off. So usually you would have in our specific case, you get a client package that arrives via the load balancer and arrives at a node where no Ingress Nginx pod would be running. kubeproxy would transparently forward it, but at the same time it will replace the client IP address, the original client IP address, with the IP address of the node that does the forwarding. So you would lose the original client IP in this, and so in your web server logs, you would only have the source IP of the node that forwarded the traffic. So to circumvent this, you have the external traffic policy option in a service, which forces the nodes without any service endpoints to remove themselves by failing health checks. So that means all the nodes that don't have a pod running off the service don't accept any traffic, and they don't accept any traffic from the front-end load balancer by failing the health checks of the cloud load balancer. So Google Cloud Load Balancers have usually health checks configured. I tell them to which nodes physically forwarding the traffic, and this looks then like this. So usually in a healthy situation, we would have this, that all the backends would have a healthy load balancer or a healthy health check in this case. But due to the way the external traffic policy was configured to local, Kubernetes now acts in a way that says, okay, the health check is only succeeding on those nodes which have a pod running, and all the nodes which don't have a pod running, we fail this. So we don't receive any traffic for the service on the other nodes, only on those nodes that actually run this pod. This is just to make sure your original client IP from wherever the request comes doesn't get replaced with one of the nodes IPs, because normally you would want to have original client IPs in your web server logs. Okay, so this was then the actual situation we had after we added a second node pool. We didn't notice this because after adding the node pool, everything was still running fine as long as we didn't train the first node pool. But yeah, as we trained and cordoned the first node pool, the situation was this: the old nodes with the Ingress Nginx pods still running got completely removed from the load balancer's backend pool, and the new nodes which did not have the Ingress Nginx pods running yet failed the health checks. So the end result was that no traffic could be reaching the Ingress Nginx pods anymore, because those nodes said, okay, we don't have any Ingress Nginx pods running, so we failed these health checks, and the old nodes were already removed because those nodes were not in a not ready state. Yeah. What did we do then? Actually, we took quite some time to really find out the root cause of all this. In the end, it was pretty simple to recover from this. The obvious solution was because the drain operation was stalled due to some misconfigured disruption budgets, as I mentioned, which we didn't need. So we didn't intentionally configure those. They were kept from a Helm charts default, which we later then noticed, removed those. And also, the simple workaround in this case was we manually deleted the pods of the original node pool, and afterwards they got recreated then on the new nodes that were in a ready state. And after that point in time, everything was working again. So this was like a quick overview, but actually took us some hours to really figure out what was going on in the background and put together all this stuff to find the root cause of this. So we have some bottom line on that. Obviously, don't blindly trust any deployment manifests, even if they are from the official Kubernetes Ingress, Nginx repositories. Check all the service and deployment definitions if they really match your environment, or and that you really understand the options that are configured there. Check them twice, or maybe even a third time or fourth time. And one big thing was we drained all those old nodes at once. So all 3 nodes, we say, okay, drain them. If we just would have drained one node at a time, we would have catched the error much earlier. So we wouldn't have any outage of traffic, because we at least would have the 2 or at least one other node running with still one reachable pod. So this is also something we learned. We don't do this anymore, that we drain all nodes at once, because now we don't have the positive experience from the past that it works flawless all times. Now we know what can go wrong, and obviously always have some observation of the behavior of your system. So anytime you notice any unforeseen consequences that are happening, quickly react and have some mechanisms in place to find those types of errors earlier rather than later. Okay, then thank you for your time, and I'm happy to answer any questions you might have.
I mean, if you have any questions, please unmute yourself and just ask. We have about 10 minutes for question. So please, if you have any question about what you just described, what you just presented to us, please unmute and feel free to ask any question. All right.
Okay, so Marcel, I have a question. So you noticed your application stopped. There was no traffic being served anymore in your cluster, right?
Yep.
That was the first thing you noticed. But what was the first thing you checked when you realized that there was no application that was able to communicate with the internal REST request?
Yeah. So first thing really we checked was just check the so was kind of intuition, really check the Ingress deployment. Mm-hmm. And see that the pods were still running. So they were still running old pods. Like it was the first thing that sprang into my eye, that they were still like over a week or something like that. Also, they were not moved off yet. So then I checked on which nodes they're really running, and then I saw they were running on the old nodes. But at this point in time, I really didn't know what was going on behind the scenes. So but having some clue that it might be actually this, as they are still running on the old nodes, but we have new nodes. I try to run into this direction and so see what's going on there. And yeah, after we took a happy guess, I would say, I deleted one of the Ingress engine exports and saw it being coming up on one of the new nodes and accepting traffic again. And after that, I really confirmed that it's because of the pods were still running on the old nodes, but it still could not really explain why it was. And then we started to investigate deeper on like the service configuration and stuff, and then it actually was like many hours of digging through documentation and through the source code to really see where it come from. But the first step was really like some kind of intuition: restart one of those pods, delete it manually, and see what happens when it restarts on one of the new nodes.
Was it possible, if looking at logs initially could have shown like that the Ingress controller weren't properly placed in the right nodes?
That would be, so we didn't look into this direction at first, actually. The next thing was that I looked at the GCP load balancer config and saw that the backends was missing to the old nodes. So the old nodes were removed from the backend config, and only the new nodes were in there. But the logs did not really show anything about this because the logs simply stopped. There was no traffic coming into the Ingress pods anymore, so they didn't really produce any log outputs anymore.
Okay.
I have a question myself. Could it be possible if you just not draining the nodes in the first place, just mess with the load balancer in the cloud just to direct your traffic to the new nodes? Then at that point, you drain the nodes afterwards. Would that be a better solution?
Yes, it depends on what you want to reconfigure manually on the cloud load balancer, because usually this is configured by the Kubernetes service controller itself, and the health check that's around those. You would not want to manually reconfigure it, because then you fight with what the Kubernetes service controller is doing with the cloud load balancer. But yes, you could have done this, that you manually added a health check to the cloud load balancer to also still point to the old nodes still. So actually the old backend config was, or the old nodes were removed from the backend config by the Kubernetes service controller, but we could have re-added them manually again. But if we kept this as it is and just drained the nodes, this wouldn't have changed anything, because the external traffic policy set to local in the service definition itself causes all the nodes that don't have pods running on them failing those health checks. So you would need to reconfigure those health checks on the cloud load balancer to not fail, even if the kube proxy on the node says it is failed because no pods are running on the nodes. So
what about like changing the deployment strategy, like a canary type of, like you say, draining one node at a time is kind of similar thinking process. So you deploy the new nodes and move the traffic one node at a time into the new nodes. Then it's like a slow process, slow percentage of traffic.
Yeah. So yeah, right. So one thing would have been either to drain one node after another. Also, second option could have been to just raise the replica count of the Ingress deployment. So we had, in this case, we had 3, and just say raise the replica count to more than 3 that we have. So the new pods are running actually on the new nodes that are not cordoned. And what also would have been an option that came to mind only after we ran into this error, if we would have configured the Ingress controllers as daemon sets instead of deployments, we would have made sure that Ingress pod runs on every node, and then also we wouldn't have run into this error.
Yes, definitely. That's another good idea. Thank you.
Right.
Okay, any more questions?
I wonder if if some of the issues that you came across was something that was specific to Nginx controller, and maybe using something like Contour, a different kind of controller out there would have been maybe better designed for that node strategy you had.
As far as I understand, this would not have helped because it was really the external traffic policy option and the cloud load balancer in the front end that it does here. So it wouldn't have mattered the actual application behind. So if it is an Ingress Nginx that runs behind this service with this external traffic policy configured to local, or if it might be traffic or Envoy proxy, this shouldn't have made any difference because the issue was really that the front end traffic did not get redirected by Kubernetes to the actual Ingress pods in the first place.
Now I have a question. My question is, I mean, I'm trying to understand something. You said anytime an instance fails in L check, right, it gets removed by the load balancer, right? Is that what you said?
No, not actually. So what happens when a node becomes not ready, the Kubernetes service controller removes it completely from the load balancer backend config.
Oh, the backend config.
And when you configure the service, the Kubernetes service as external traffic policy local, the proxy makes sure that all those nodes that don't have a pod running endpoint locally on this node, then those will deliberately fail the health checks of the cloud load balancer.
Because I'm thinking of this from like AWS perspective, right? Because for if you are doing this kind of upgrade in AWS, right, the load balancer, despite the fact that if you scale up, if you bring in new node, right, those nodes, provided they are all in the new autoscaling group is pointing to the load balancer, right? The old autoscaling group is pointing to the load balancer. So the old ones, those tools are still going to be pointing to the load balancer. And what you can do is after the new autoscaling group comes up, then you can scale down the old one. That's like, you can completely remove them, right? So I'm thinking how this could, because I work with AWS a lot. So from GK perspective, I'm trying to understand if it's exactly the same setup, but from what I'm thinking, it's totally different from AWS.
Well, yeah, might be. Actually, I don't have really AWS experience,
Yeah.
So we have all our stuff in GKE. So
well, I think you're mixing two different things up. So with the Nginx controller, how it works under the cover, it's just a plain old Nginx, and then you for the actual worker ones, and then the controller just does management. And what it does is it watches the Kube API, and anytime a pod inside that service definition changes, it goes up, out, gets the IP address of that pod, and then gets the update, builds an updated config and pushes it down to any of the Nginx actual worker threads that are sitting on the host running. That's why. So I know Rancher, because that's what I work with. By default, we push a Nginx controller to all nodes in the cluster, including etcd, worker nodes, control plane, everything. So the simple fact that then all hosts in the cluster automatically can service all requests. I think that's really the root problem of this issue. Was you had some nodes that couldn't service requests, and he just so happened to drain all the nodes that could service requests at basically the same time.
Yeah, that's right.
Yeah.
Right. This is good. I think we are way past time. So, does anyone have just one last question? This is actually very good. All right. So if no one has any question, thank you very much, Marcel. Did I pronounce your name right, Marcel?
Yeah, that's right, Marcel.
Thank you very much for sharing this with us. The point of this is to engage, to bring up discussion. For example, something happens like right now, I'm going back to my Helms chart. I'm looking at all my services right now, and I'm looking at their policy type. I'm going to do that because of what you just mentioned right now. This is the point of this meetup, this series that we have to invoke, because one thing about Kubernetes, when everything is going right, everybody's happy. When something goes wrong, everybody's like, where do I start?
Yeah, right.
So being able to watch, what other people have done and how they've corrected it is very, very helpful. So thank you very much for this. Thanks.
Hey, Marcel. Hey, Marcel, are you going to make the slides available?
Yes, I will send around the link in the in which of the meetup groups. I would say in all of those. So I can do this. Actually, those are reveal MD slides in a GitHub repository of mine. So I will send the link around. Yes.
All right. Or you can just send it to me.
Thank you.
Everybody.
Yeah. Okay. Great.
And I think lastly, Matthew raised like a really interesting point about how Rancher uses Nginx controller on every node. And so it's quite different because, with the GCE setup, it's different. You had your Nginx controller running on a single node, I'm assuming. But with the Rancher setup, it is more like, it's more tightened for HA purposes. So when you lose a single node, you can still receive traffic using the Ingress, unlike, the setup you had.
Yeah. So the root cause was that we that we had removed all the nodes still, which had an Ingress controller. Yeah. So yeah. There's something to really watch out, depending on which provider you go. Which really check those circumstances before you go into production, ideally, and not just blindly trust that it all will work out. Because you have some positive experience from any other provider, it doesn't necessarily mean that the new one you might be using is doing the same stuff to make you happy. So really check those configs before you put stuff into production.
All right. I'm going to go ahead and check on my Helm charts and see
those pod disruption budgets. So we didn't check for those and run right into them.
All right. Yeah, I will. Thank you very much for sharing this. I'll go ahead and end the meeting. If you have any question, please, can you share your Twitter handle on the room so that people can follow you? Stuff
yeah,
like that?
Of course. A second. So this is my.
Hey, Tunde, did you record this?
Yeah.
Is the recording going to be available
right now? Yes. So we are going to make.
Okay. So will you make?
Yes.
You're going to make the link available because I would want to listen to this thing again because I missed the initial part of this.
Okay, no problem. I will make it available and let everybody know it's available. Yeah, I will do that.
Also,
perfect. Thank you.
If you have like a Kubernetes failure story that you would like to share with everyone here and the whole community, please reach out to me or me throughout using the Slack channel or via the meetup link. We definitely would be willing to take Kubernetes failure stories.
All right. This is going to be the end. Thank you very much. Oh yeah, you just posted the link to the slide.
Yeah, right. So it's in, as I said, real MD format. So just plain text with some notes and the pictures in there. So yeah.
All right. Thank you very much.
Okay. Yeah, has been my pleasure.
All right. That's it. We've come to the end. So thank you very much. And hopefully I will see everybody, in our next meeting. Thank you all for coming. Like, please, if you have anybody, just like, Babatunde said, that has a story. There's something must have happened in production. Trust me. Everybody has that story. But, the more we share those stories, the better it's for everybody. You know, right now I have like a bunch of things I'm planning to do in my head right now because of what you just shared. So thank you very much. Thank you. All right. That's it.
Thank you.
Yeah, thanks for listening to me.
Thank you, Marcel.
So have a nice evening, everyone.
All right.
Okay, bye.
Thank you. You too. Bye bye.